All right, everybody, what's going on? This video, we're going to look at triple integrals. Now, in the past, you've found the area under the curve. We found the volume of a surface over a region in the XY plane. All right, we found the volume under that surface over a region in the XY plane. And that was double integrals. Finding the area under a curve, that was a single integral. Now let's look at triple integrals. So if we had this box right here, and we take this box and we break it up into a bunch of smaller boxes, what we can do is we can find the volume of each of these boxes, and then we sum those boxes up, sum those volumes up. And so what I've done here is I've taken this little box here, and I just drew one of them. You got to imagine this thing's full of boxes, okay? And I brought it over here, and you can see here we've got this width delta y, delta x, and then we got the height on the box delta z. And we can find the volume of this box, and the volume of all the little boxes, and we can sum all those up. So we have a definition here. It says the triple integral of f over the box b is, and so we've got triple integral over the box b of f of x, y, z dv is the limit as L, M, and N go to infinity. And it's the sum of f of x I, y, I, z, k times delta v if this limit exists. Okay, so it's a triple Riemann sum. All right, and then we've got Fubini's theorem for triple integrals. If f is continuous on the rectangular box B, which is AB by CD by RS, then this integral is the integral r to s, c to d, a to b of f of x, y, z, dx, dy, dz. Now, what we're going to do is we're going to evaluate these integrals. This first example, it'll be pretty easy. It's pretty straightforward. But later on, when we get into these examples, the hardest part is going to be actually setting them up. Okay, you've done some setting these integrals up when we did the double integrals. It's just we got to set up another integral. Okay, we're going to have 3 instead of 2, and so we'll go through that, and hopefully by the end of this video you will understand how to set these things up, because that's really probably the most difficult part to do. All right, so let's look at this first example. It says evaluate the triple integral x, y, z squared dv, where b is the rectangular box given by, all right, x is between 0 and 1, y is between -1 and 2, and z is between 0 and 3. All right, so let's go ahead and set up this integral. All right, so we're going to go over this region B here of x, y, z squared dv. All right, and that is going to equal, all right, so we'll just start on the first one. We'll do 0 to 3, that's for the z, and then we'll go from -1 to 2, that's for the y here. And then we'll go from 0 to 1, and that's the x, and that's of x, y, z squared. And that's going to be what? dx, that's what we're integrating with respect to on the first one. And then we've got dy, that's the -1 to 2, and then dz. All right, now I've set it up, and you might be wondering, well, why did you do the dx first, then the dy, then the dz? Well, that's just what I chose to do. You could have done dz, dy, dx. Of course, you know, the numbers would have changed here. They would have been on different integrals. And in another example, I don't know if it's the next example or the one after that, but in one of these examples, we're going to actually set an integral up 6 different ways so you can see it. Okay, so for right now, I just chose to go dx, dy, dz. You could change this order if you want. All right, so now let's go ahead and see what we get. All right, so we're integrating with respect to x first. And so that's going to be 0 to 3, -1 to 2, and that's going to be 1/2 x squared y z squared. Okay, and that is going to be from x equals 0 to x equal 1 dy, dy dz. All right. So now let's see what we get here. So that's going to be 0 to 3, -1 to 2, and now I've got to evaluate this from 0 to 1. So I'm plugging the 1 in for x, and I'm plugging the 0 in for x. And keep in mind the 1/2, the y, and the z squared, those are like constants. So I can actually just write 1/2 y z squared times, and then I can plug the 1 in for x and then the 0 in for x. So I've got the 1 squared minus 0 squared. Okay, and this is like a constant times that, and then that's dy dz. And so this is going to give me 0 to 3, -1 to 2, and this is just 1 here, so that's going to be 1/2 y z squared dy dz. All right. Now let's integrate with respect to y. And so this is going to be 0 to 3, and then integrating with respect to y, the 1/2 and the z squared, those are like constants. So integrate y, that's going to be 1/2 y squared. So 1/2 times 1/2 is 1/4 y squared z squared, and that's going to be y equals -1 to y equal 2 dz. All right. And so then we evaluate this. That's going to be 0 to 3, and that is going to be 1/4 z squared times, and now I'm going to plug the 2 in for y and the 1 in for y. So that's going to be 2 squared minus -1 squared, and that's times dz. And so that's going to be 0 to 3, 1/4, and let's say that's going to be 4 minus 1 is 3. Yep, z squared times 3 dz, and that's going to be 0 to 3, 3/4 z squared dz. All right, now let's integrate with respect to z, and so that's going to be 1/3 z cubed. So 1/3 times the 3/4 is going to be 1/4 z cubed, and that's going to be from 0 to 3. And so that's going to give us 1/4 times 3 cubed minus 0 cubed, which is going to be 27/4. And there's your answer. All right. So it's not bad. It's that this problem here really wasn't much different than when you did double integrals and you had the numbers, you know, your limits on the integrals were numbers. Pretty much the same thing. You just had to integrate one more time. Okay. All right, so let's look at this. Triple integral over a general bounded region E. Okay. So let's look at an example here and see what we've got. it says evaluate the triple integral over a general region E of z dv, where E is the solid tetrahedron bounded by the four planes x equals 0, y equals 0, z equals 0, and x plus y plus z equals 1. All right, so the thing that we have to do here is we need to make a sketch. Okay, so let's sketch this out. So I've got my x, my y, and my z. All right, now if I have x equals x and y, let's just do x and y equals 0, then that means z is equal to 1. If I plug in the 0 for x, 0 for y, I get z is equal to 1. And then if the x and the z are 0, then that means y is equal to 1. And if the y and the z equals 0, then that means x is 1. So this gives me the point 0, 0, 1. This gives me the point 0, 1, 0. And this gives me the point 1, 0, 0. And so let's go ahead and mark that off. Right here. All right. And this is x, this is y, and this is z. All right. Now, we're going to set this up. We're going to integrate with respect to z first, y second, and x third. Okay, we'll have dz, dy, dx. Now, in this problem, I'm going to set this problem up 6 different ways. Okay, so the first way, dz, dy, dx. Okay, I'm gonna integrate with respect to z, then y, and then x. All right, so let's see what we've got here. All right, so I'm integrating with respect to z first. So I've got to get the bounds for z. So for z, I'm going from z equals 0 up to this plane here. See, this looks like a triangle to this plane. So what we're doing here is we're going let me bring that up a little bit more. So we're going from the XY plane, okay? So think about it. On the XY plane, z is what? Z is 0, right? And we're going up to this plane right here, this tetrahedron. And so what's the equation for this? Well, we know it's x plus y plus z equals 1, okay? But we need to solve this thing for z. And so we know z is equal to 1 minus x minus y. So if you look at this first integral is going to be 0, okay? So from the xy plane 0 up to this plane right here, which is 1 minus x minus y. See, we're doing with respect to z first. Okay, let's just go ahead and put the z right here. And we're integrating with respect to dz. Integrating with respect to z, so that's the dz there. And we're going up to here, so we're going to need this in terms of x and y. So we solve for z, so that's going to be up to 1 minus x minus y. Okay, now we're going to integrate with respect to y. Okay, so how do we do that? Well, that's going to look like this. We're going to have to draw us another picture. And we know that's 1, that's 1, this is X, this is Y. So it's like we're standing up here and we're looking down on this area right here. You see that? We're looking at this area and I just brought it over here. See, this right here is the point 1, 0, 0. This is the point 0, 1, 0. And this is the point 0, 0, 1. Okay? So you can see it crosses the x-axis at 1, it crosses the y-axis at 1. Okay? And what we need to do is we need to come up with an equation of this line right here. So we can see that the slope is -1. It has a y-intercept of 0, 1. Okay? And so I know this is going to be y is equal to -x plus 1, -x plus 1. So instead of writing -x plus 1, let's just write it as 1 minus x. No big deal. You can leave it as -x plus 1, but let's just write it as 1 minus x so we don't have that minus as the leading term. Okay? And we're going to go this way on the y-axis. So we're going from 0 to what? To this line right here, right? All right. And so we're going from 0 to the line, which is 1 minus x. And so that's going to be dy. And then we need dx. And you can see dx, on the x-axis, we're going to go from 0 to 1. 0 to 1. And there it is. It's set up now. Okay? And I'm going to go ahead and evaluate this integral. And then we're going to set it up 5 other ways. But I'm not going to evaluate those integrals. It'll be similar to what we're doing here. Okay? So let's go ahead and see what we get here. And so this is going to be 0 to 1. 0 to 1 minus x, and then the antiderivative of z, that's going to give us 1/2 z squared, and that's going to be from z equals 0 to z equals 1 minus x minus y dy dx. All right. So now let's evaluate. So this is going to be 0 to 1, 0 to 1 minus x. And so now we're going to plug this in for z and plug this in for z. Okay? All right, so that is going to give us 1/2 times 1 minus x minus y. And that is going to be squared. And then I plug the 0 in. Well, what is that going to give me? That's just going to give me 0 squared, right? When I plug the 0 in for z, that's just going to be 0. And then that's dy dx. All right. And so that is going to give us, let's see, 0 to 1, 0 to 1 minus x. And then that's going to be, now, that's the one, we got the 1/2 there, but let's go ahead and that's an x there. Let's go ahead and bring the 1/2 out. And so that's going to give me 1 minus x minus y squared dy dx. All right. So now what do we need to do? Well, now we need to integrate with respect to y. And so for this one, hopefully you can see that we need to use u substitution here. Okay, we've got to use u substitution. So to do that, we would let u equal 1 minus x minus y. And so du is going to be what? Negative dy. All right, because remember when we're taking the derivative with respect to y, so everything else is like a constant. So this is just -1 dy. Okay, and you can see when I go to replace this with u, okay, I would have u squared, and then I would need a negative here because I've got a negative dy. You see that? So I would need a negative, so I would need a negative out here. So basically what I have when I make the substitution of u, I would have u squared, right? Because the negative dy, that's being replaced with du, and then the 1 minus x minus y is being replaced with u, so that's u squared. So that would actually be what? 1/3 u cubed when I integrate that. All right. And then I'm going to take this and plug it back in for u. Okay. Hopefully everybody sees that. And so that will actually give me negative 1/2, the negative 1/2 right here. And that's going to be from 0 to 1. And then when I plug the 1 minus x minus y back into here, that's going to actually give me 1 minus x minus y cubed over 3. And that's going to be from y equals 0 to y equals 1 minus x. All right, let me erase this. So, I didn't show, I showed most of the steps on the u substitution. I just kind of went off here to the side and did it. Okay. You should be at that point now where, you can do that kind of stuff. And so, of course, we've got dx. So now I need to evaluate this. Okay. And so that's going to equal negative 1/2, 0 to 1. And so now I've got to take the 1 minus x and plug it in for y. So that's going to be 1 minus x minus y, but in the place of y, I'm going to put 1 minus x, and all of that is cubed over 3 minus, and then I've got to plug the 0 in for y. And so that's going to be 1 minus x minus 0, all of that cubed over 3. And that is, put a bracket there, and then I've got times the dx. All right, so let's see what we have. Now, hopefully you can see here 1 minus 1 is 0, negative x plus x is 0. This term right here is going to go to 0. And so that's going to leave me with negative 1/2, okay, negative 1/2 integral 0 to 1, and that's going to be 1 minus x cubed over 3 dx. And I'm going to go ahead and write this one more time, okay? And I'm going to put this as negative 1/6, 0 to 1, 1 minus x cubed over 3 dx. All right. And I'm sorry, this right here, that should be a positive. I had a negative here, but that should be positive because look, and see this is a negative in front. I forgot to bring this negative with it. Okay, and so that's going to make it a negative and negative, make it positive, and then the 3 times 2 is the 6. All right. And if I do that, I don't need the 3 there. Let me write that again. Boy, what a good way to start on this problem, huh? All right. And so then once again, we would do the u substitution, let u equal 1 minus x. Du would be negative dx. See, we would let u equal 1 minus x. Du would equal negative dx. So we've got a negative, negative. So we have negative dx. This gets replaced with u. And this is going to be 1/4, right? It's going to be 1/4 x minus, 1/4 1 minus x to the 4th. So 1/4 times negative 1/6, that's negative 1 over 24. times 1 minus x to the fourth, and that is going to be from 0 to 1. And so that's going to be negative 1 over 24 times, and that's going to be 1 minus 1 to the fourth minus 1 minus 0 to the fourth. And so this goes to 0. This is going to be negative 1. Negative 1 times negative 1 over 24 is positive 1 over 24. And so there it is, evaluated. Okay? All right. So remember, the first thing we did is we set this up z, y, x. That's the order of our integration. Z with respect to z, then y, then x. And as promised, I said I would set it up 5 more times. Okay? So the first one was z, y, x. So for this one, let's go z, then x, then y. And just real quick, I'm gonna sketch that graph. Okay. This is x equal 1, this is y equal 1, and this is z equal 1. Okay. So I'm gonna go with respect to z, then with respect to x, then with respect to y. And all we're gonna do is set it up. Okay. All right. So let's see what we get. So let's go with respect to z, and this is going to be just like in the first one. All right, z is going from 0 up to this plane right here. And remember, this is z equals 1 minus x minus y. So on the z, we're going from 0 to 1 minus x minus y. And this is what? Z dz. All right, so now we're going to go with respect to x. All right, so we need to draw this over here, this triangle here. We're going to look at it in the xy plane. And so to do that, let me draw that a little better. Okay. I'm just drawing what I had drawn up there at the first. So there's 1, there's x, and there's y. But now we're going to integrate with respect to x. So the x is going from 0 to that line. And if you remember, this line was y equals 1 minus x, right? But we're integrating with respect to x, so we're going from 0 to some point x, right, on this line. Well, to some x value up here that hits that line. Well, what is x? Well, x is 1 minus y if we solve this for x. And so we're going on the x, we're going from 0 to this line, which is 1 minus y. And then for y, we're going from 0 to 1. 0 to 1. And there's that one set up. Okay, and then you would integrate, do, pretty much like we did in the first one. Okay. All right, so that's going z, x, and then y. All right, so let's set it up way number 3. All right, so this time let's go with y, then z, and then x. Okay, so we did with respect to z first, and then we did with respect to y, and then x, and then z, x, y. Now let's set up with respect to y first, and then zx, and then we'll do y, x, z. And then we'll do the x with each of them swapped. All right, so let's go ahead and sketch the graph real quick. Now, let's see what we've got. So we've got this, we've got z, and remember, we're integrating with respect to y first. So we need to see how we're moving on the y-axis. So remember, y is 0 right here. See, we're coming out this way. Okay, so y is going from 0 to this plane right here. Now remember our plane was what? X plus y plus z equals 1. So what do we need to do? We're going along the y-axis. So we need to solve this thing for y. So this is y equals 1 minus x minus z. So we're going from y equals 0 to y equals some point on this plane here. So that's going to be to 1 minus x minus z. 1 minus x minus z. All right. And then we're going with respect to z, so dz. So what is that going to be? Let me erase this. All right. And so what we need to do here is we need to draw this triangle right here. Okay, this is x, y, z. Okay, and we're looking at the xz plane, and it's going to look like that. See, x is at 1, z is at 1. That's this line right here. Okay, and we're integrating with respect to z. So we're going on the z-axis. We're going from when z is 0 up to this line right here. Now, what's the equation of this line? Well, you can see the slope is -1, and it intercepts the z-axis at 0, 1, and so this is going to be what? It's going to be x equal -z plus 1. See, the z is like your y-axis now, so it's going to be x equal -z. I'm sorry. It's going to be z equals -x plus 1, which is going to be 1 minus x. All right. Now, what's going to be my limits? Well, I'm going to go from 0, right? From 0 up to this line, okay, on the z-axis. So what is z? Z is 1 minus x. Z is 1 minus x. And then we go along the x-axis. That's from 0 to 1. So that's 0 to 1. And then we've got the dx. Okay. So there's that one set up. All right. Now the next way. All right, so here I did y, z, x. Now let's do y, x, z. And let's sketch this real quick. X, y, z. And got something like this. Okay. So once again, in the y direction, this is from y equals 0 to this plane here. Okay, and so that's gonna actually give me, and remember this is y equals 1 minus x minus z. Okay, we're still doing the y first. And so that's going to be from 0 to 1 minus x minus z of z dz. Now I need to go with respect to x. Okay, with respect to x. So look at this. It's going to be, we're just going to use this again. So I'm going this way. So I'm going from 0 out x units. Well, what's x? X is equal to 1 minus z. You see that? So this is going to go from 0 to 1 minus z. And then along the z-axis from 0 to 1 up here. So 0 to 1, I've got my dx, and then I've got my dz. And there's that one set up. All right. All right, now, oh, and I have run out of room, haven't I? All right, so let me erase, I'm going to erase this one and this one to get the next two in. All right, so I got that erased. I drew this again. We're going to go x, let's do x, z, and then y. All right, so now I'm going in the x direction. So x is 0 back here. Okay, so I'm going from x equals 0 to the plane. Okay, to the plane. And so that is going to give me the integral, and that's what x is 0 out to the plane here. And remember, this is x plus y plus z equals 1. So we need to solve this for x. So x is equal to 1 minus y minus z. And so that's 1 minus y minus z. And that's z dx. All right. And then we've got to look at this rectangle right here. Okay, in the YZ plane, the YZ plane. And of course, we're still at 1 and 1 right here. That's 1, that's 1. And we're going with respect to Z first. Okay, so I'm going here. All right, and what's the equation of this? Well, you can see your slope is -1. The y, or the z-intercept, I guess you could say, is 0, 1. And so this is going to be z is equal to 1 minus y. All right. And so for z, we're going from 0 up to this line, which is z equals 1 minus y. 1 minus y. And that is dz. And then with respect to y, we're going from 0 to 1 right here. 0 to 1. And then let's go with respect to x, and then y, and then z. Okay, so let's set that up. All right, so we can just look at these pictures here. So we can see for the x, that's going to go from 0 to 1 minus y minus z, okay, just like this one up here. And that's going to be z dx. Then we're going with respect to y. And so I'm going to erase that, and that's y is going from 0 out to this line. So I'm going to need this in terms of y. So y is equal to 1 minus z. So that's going to be y goes from 0 to 1 minus z. That's dy. And then we do dz. dz is going from 0 to 1. 0 to 1. And there's that one. So there's the 6 ways you can set that up. Now, which one's the easiest to integrate? I don't know. It might be the first way we did it. Okay, but you know, there's not just, it's not just one way that you can set these up. So All right, so let's take a look at this next example. It says evaluate the triple integral over the region E of square root of x squared plus z squared dv, where E is the region bounded by the paraboloid y equals x squared plus z squared and the plane y equals 4. All right, so first thing we want to do is let's go ahead and draw a picture. All right, so there's x, y, and z. And I'm going to graph this paraboloid here, y equals x squared plus z squared. So that's going to be something like this. We've got a paraboloid right here. And so that's this paraboloid y equals x squared plus z squared and the plane y equals 4. So that's a plane where all the y values are 4, x and z can be anything. And so we're out here at, well, I mean, I guess we could call it right in there at 4. That would be our 4 right there. All right. And this is y equals x squared plus z squared. That's this graph right here. And it's a paraboloid. Okay. I want to make it look a little more three-dimensional. All right. So how do we want to integrate this thing? What do we want to integrate with respect to first? X, y, or z? Well, let's integrate with respect to z first. Okay. So I need to get this graph here in z equals something. And so you can see we move the x squared over, and that's going to give me z is equal to plus or minus the square root of y minus x squared, right? And so remember this top part right here, that's z equals the square root of y minus x squared. And this part right here is z equals negative square root of y minus x squared. All right. So what I have here is I've got the integral, and I'm integrating with respect to z first. This is going to be the square root of x squared plus z squared, and I'm integrating with respect to z. So you can see we're going from what? Negative from this function to this function. All right, so I'm going from negative square root of y minus x squared up to square root of y minus x squared. Okay. Then let's integrate with respect to y dy. All right, so I want to look at this thing in the xy plane. All right, so let's draw this. There's x, there's y. Let's draw it on over. And if I'm looking in the xy plane, standing up, and I'm looking down, do you see that it's gonna look like a parabola? Okay, it's gonna be this parabola right here. Y equals x squared. Okay, see, if z is 0, we get y equal x squared. All right, and it's bounded by the line y equals 4. All right, so I'm integrating with respect to y, and so I'm going from here up to here. You see that? So my y value is going from this graph right here, from y equals x squared, so x squared, all the way up to where y is equal to 4. Okay? And then my x, you see that? Well, where does this graph intersect this line? Well, that's where See, I've got y equal x squared and I got y equals 4. So they intersect when x squared equals 4, or where x is plus or minus 2. And so that's negative 2 to 2. So x is going from negative 2 to 2. And then we've got the dx. All right. So there's that one set up. And now we could be ready to integrate this thing. Okay, we can integrate it now. So how are we going to integrate this? Well, we're integrating with respect to z, and we've got a z squared here. We don't have a z term out here. This one right here is difficult to evaluate. Okay, we don't want to do that. We want to see, is there something easier to do? Okay, and this is where it comes in handy when you get real good at setting these things up. Okay, so let's go ahead and change this to where, I don't know, I mean, I guess we could integrate with respect to x. We could integrate with respect to y first. Let's try integrating with respect to y. Okay. So integrate with respect to y. So we've got this. We're still looking at this graph right here. Okay. So let's just kind of maybe, I don't know, maybe modify it a little bit. Let's take these labels right here off. I don't know. Well, let's leave them on there. All right, let's leave them on there. Okay. So we're going to integrate with respect to y first. So if I look at that, I'm coming along the y-axis right here. So I'm going from here all the way out to here. You see that? There's on the y-axis. See, and I can come down here, we'll go to, something like that. But we're going along the y-axis, okay? And so I'm going to get, and let's just copy the problem down again. That's square root x squared plus z squared dv. And that is going to equal, okay, so I'm going to integrate with respect to y first. So I'm going from this point here, which is what? What's this? What's the equation of this right here? Well, that's y equals x squared plus z squared, right? That's what I'm going from. Y equals the x squared plus z squared. So that's x squared plus z squared, all the way to what? To where y is equal to 4. Okay. And then let's go along the z-axis. Okay, so let's look at this in the xy, and well, not the xy plane, but the xz plane. So I'm gonna erase this. I just want to make sure I have enough room to work this problem. All right, so if I look in the xz plane, that's going to be a circle, right? That's like I'm standing over here and looking back this way, I see a circle, okay, for the paraboloid. And do you understand that circle, this biggest circle, would be x squared plus z squared is equal to 4. And then as I go in and I look at more of these circles, the circles that I'm doing, x squared plus z squared, they're going to basically be less than or equal to 4, right? They're going to be less than or equal to 4. That's going to be the largest one. And it'll go all the way down to this point right here. And we know this is -2, and this is 2. This is x, this is z. And so the x squared, this big circle here, x squared plus z squared equals 4. It has a radius of 2. So there's the -2 and the +2. But look at this. I'm going here, the top of this circle, this would be what? Z equals the square root of 4 minus x squared, and this bottom circle would be z equals negative square root of 4 minus x squared, right? And so if I look at on the z-axis, you see that on the z-axis, I'm going from negative square root of 4 minus x squared. Because see, I'm going like this. Okay, so I'm going from negative square root 4 minus x squared to square root 4 minus x squared. And I'm going to rewrite that so it's not all jumbled up. Negative square root 4 minus x squared, square root 4 minus x squared. And then this one was, what was it, x squared plus z squared to 4. And it's actually square root x squared plus z squared. And that's dz and then dy. And then I've got to go on the x-axis. Well, the x-axis, I'm going from -2 to 2. So that's going from -2 to 2. All right, so now, oh, and this is dx right here. All right, so now let's look at this. So, well, we got to integrate this. We're integrating with respect to y first, right? We're integrating with respect to y. Now, that's easy to do because look, you see this right here? That's just like a constant. That's like a constant there. And so this is going to give me -2 to 2 and negative square root 4 minus x squared to square root 4 minus x squared. And that's going to be what? Y square root x squared plus z squared, right? And that's going to be from y equals x squared plus z squared to y equals 4 dz dx. All right. And then we're going to plug, we got to plug this in for y. And so, I don't know if I got enough room there. Let's see. So we're going to go from -2 to 2, and then negative square root 4 minus x squared to square root 4 minus x squared. And so that's going to be 4 minus x squared plus z squared. All right. I plug that in for y times the square root of x squared plus z squared. Remember, this is just a constant. I'm plugging the 4 in for y, and then minus, and then I'm plugging the x squared plus z squared in for y. And that is dz dx. All right. All right. So now we have the privilege of integrating this thing. And I mean, is this much better than what we had? Well, let's think about how we can do this. Well, I think I may have an idea. Let's do this. Open up some program. So let's convert to polar coordinates in the XZ plane. Whoop. Okay, so that would be x is equal to r cosine theta, z would be equal to r sine theta, and then I would have r squared is equal to x squared plus z squared. All right, so let's change it. So I've got my integral, all right? Okay, so remember, we'll have to change our bounds also, won't we? All right, so we'll change the bounds last. Let's plug this in. So I've got what? I've got 4 minus what? 4 minus r squared, right? See? Okay. All right, I don't know, I hit something again. Sorry about that. So look at this. Oh, where is it? Here it is. X squared plus z squared is r squared. So the x squared plus z squared, I'll replace that with r squared. So 4 minus r squared. And then that's going to be times, and look at this, the square root of x squared plus z squared, that would just be r, right? So r. And then remember, so that right there is replacing everything, okay? And then remember what it is. It's times r dr d theta. Don't forget you've got to multiply times that r there, okay? Now let's get our limits. So let's come back up here. So r, that's 0 to 2, right? See, that's 0 to 2 is r, and then theta is what? 0 to 2 pi. Okay, and so r would be 0 to 2, theta 0 to 2 pi. Okay, we've done this, double integrals in polar coordinates. That was an earlier lesson. Okay, all right, so this is going to be 0 to 2 pi, 0 to 2, and then we will end up with 4r squared minus r to the 4th dr d theta. And now, I mean, you can see now this is going to be easy to evaluate. And so we've got 0 to 2 pi, and that's going to be what? 4/3 r cubed minus 1/5 r to the 5th, and that's going to be r equals 0 to r equals 2. Okay. Well, I tell you what. Let's do it like this. Let's do it. I mean, we could do that, but let's do this. Remember, we can do this. We can go 0 to 2 pi d theta, 0 to 2, 4r squared minus r to the 4th dr. Remember, we can integrate, and then multiply the results. We covered that earlier too. Mind refresher right there, huh? All right, so this is going to be theta from 0 to 2 pi, and then this is going to be times 4/3 r cubed minus 1/5 r to the 5th, and that's going to be from 0 to 2. And so this is going to give me 2 pi minus 0 times, and that's going to be 4/3 times 2 cubed minus 1/5 times 2 to the 5th minus, and then when I plug the 0 in, I just get 0. And after you do all your calculations, you get 128 pi over 15. And there's your answer. Okay, so the point of this problem is, okay, we set it up and we integrated in a certain order, and once we set it up, we realized, you know something, that was pretty difficult to set up. Okay, that was difficult to set up. Well, so now, and so then what we did is we changed the order that we're going to integrate, and it made it easier to integrate for the first time. We integrated with respect to y. But then you can see once we got down to right here, well, we had something difficult there, but what did we do? Well, polar coordinates saved the day. All right. All right, so let's look at this next example. I think we got two more examples to do. All right, so use a triple integral to find the volume of the tetrahedron T bounded by the planes x plus 2y plus z equals 2, x equals 0, and z equals 0. All right, so first thing, let's draw a picture of it. All right, so let's draw this picture. So let's draw the x-axis like this and the y-axis coming back like this, and then the z. So we've got x, y, and z. All right, so let's see what we've got. So if we do x equals z equals 0, so x and z are 0, that's going to give us y equals 1. And so that's going to be this point right here. This is the point 0, 1, 0. And then if I do x equal y equal 0, then that means z is equal to 2. So if I plug in 0 and 0, I get z equal 2. If I plug in 0 and 0, I get 2y equals 2, so y is 1. And so 1, 2. So I've got 2 up here. So that gives me the point 0, 0, 2. All right. So then I need another point. Now I can have, z equals 0, and I also know that. All right, so let's take a look at this next example. So it says, use a triple integral to find the volume of the tetrahedron T bounded by the planes x plus 2y plus z equals 2. And then this x equal 2y, I forgot to put it when I was writing the notes up, and I noticed it, so I inserted it in there. X equal 2y, x equals 0, and z equals 0. So first thing, let's sketch a graph of this. All right, so we've got x, we've got our y, there's x, there's y, and then we've got our z. There's z. So to graph this thing, all right, I can let z equals x equals 0, which that's going to mean y is equal to 1. If I plug 0 in here, 0 in here, 2y equals 2, y equals 1. So that is going to give me the point 0, 1, 0. And then if I let x and y equal 0, so 0 here, 0 here, z is equal to 2. So that's going to be the point 0, 0, 2. And then we need another point on there. Well, I know that x is equal to 2y. I know x is equal to 2y. And if I say z is 0, then that's going to give me what? 2y plus 2y plus 0 equals 2, right? If I replace x with 2y. And so that's going to be 4y equals 2. So that means y is equal to 1/2. So 0, so z is 0, okay? Z is 0. Y is 1/2. What's x? Well, x is 2y, so x is equal to 2 times y, which is 1/2, which is 1. So that's going to give me the point 1, 1/2, 0, 1, 1/2, 0. And so I have got something that looks like this. And this right here, this is where x is equal to 2y. This right here is x plus 2y plus z equals 2. All right. So we need to set this thing up. All right. So notice what the problem tells us. It's use a triple integral to find the volume of the tetrahedron. Now, to find the volume, if you remember earlier when it asked us to find the area, and we went with, we would integrate with respect to x, with respect to y. We were doing the double integrals, and they asked us to find the area. What was it? It was the double integral, and it was 1 dx dy, or 1 times dA, right? 1 times dA. So in this one's going to be similar. The volume is going to be the triple integral over the region T. They call it T right here. And that's going to be 1 times dV, because they're asking us to find the volume of that tetrahedron. And so we need to set this up. All right. So how do we want to set it up? Do we want to do z first, x first, y first? Let's just integrate with respect to z first. Let's see what happens. Okay. And so if I'm integrating with respect to z first, I'm coming from where z is equal to 0, right, all the way up like this, from z equals 0 to this plane right here. Okay, to this one right here. So I'm going z equals 0 up z, right? Well, what's z? Well, I got to figure out what z is. Z is equal to 2 minus x minus 2y, right? Got to solve that for z. So that is 2 minus x minus 2y. And that's with respect to z. All right. Now we need to look in the xy plane. So I need to look at this triangle right here. I'm going to draw it over here in the xy plane. So it's going to look something like this. Okay? And remember, this is 1, and this right here is a half. So this would be the point 1, 1/2, right? See, 1, 1/2. And y is starting out at 0, 1, and x is coming from 0, 0. All right. And this is your x-axis, and this is your y-axis. Well, let's integrate with respect to y and x. So I'm going from this line to this line. So I need the equation of those lines. Well, I mean, to get to this point, I'm going to go down a half into the right one. So my slope is negative 1/2. I got a y-intercept of 1. And so this is y equals negative 1/2 x plus 1. This one, I'm going up a half over 1. So the slope is 1/2. It goes through the origin, 0, 0. So this is y equals 1/2 x. And so for my y, I'm going from 1/2 x to negative 1/2 x plus 1, negative 1/2 x plus 1. And that's with respect to y. And then with respect to x, so I'm going from 0 to 1, 0 to 1 dx. And there's that one set up. Okay. And I'm not going to go through and work this one out. The main thing here was setting it up. Okay, that's what I wanted to get across to you on this one, was setting it up. I'll do the first thing, 0, 1, 1/2 x, negative 1/2 x plus 1. And so if I integrate 1 with respect to z, that is going to be z, and that's from z equals 0 to z equals 2 minus x minus 2y dy dx. And then after you do all your evaluating and everything, you should get 1/3 as an answer. But the main thing on this problem that I wanted you to see is I wanted you to see that, to see how to set it up, because that's you know, that's the most difficult part, is setting it up. You should be able to integrate this. I've done some, we've already done some examples where we integrated, so, you know, we got that. All right, so let's look at this. It says if the density function of a solid object that occupies the region E is rho of xyz in units of mass per unit volume at any given point xyz, then its mass is m is equal the triple integral over the region E of rho of xyz dv. And its moments about the three coordinate planes are m sub yz, okay, it's x times that. It's the same as this. We just got x times. That's m of yz. M of xz is y times that. And m of xy is z times that. And so that's the moments about the three coordinate planes. And then the center of mass is located at the point x bar, y bar, z bar, which is each one of those divided by the mass, m. Okay. All right, so then we have the moments of inertia about the three coordinate axes are, okay, so for Ix, we're just multiplying the rho of xyz dv by y squared z squared. And for I sub y, that's x squared plus z squared multiplied times that. And for I sub z, it's x squared plus y squared times the rho of xyz dv. All right, so let's go ahead and look at this example. I'm not going to evaluate these integrals. We're just going to set each one of them up, okay? And I'm going to show you what you would get if you evaluated them and all that stuff. So, and this would be a pretty good problem to look at too, okay? On, you know, having to sketch it out and all that good stuff. So it says find the center of mass of a solid of constant density that is bounded by the parabolic cylinder x equal y squared. Okay, so that's going to be what? Those are parabolas in the xy plane, right? Parabolas in the xy plane. It's x equal y squared. So that parabola is going to be opening on the x-axis, right? And the planes x equal z, z equals 0, and x equal 1. All right, so let's see if we can't draw a sketch of this. So we've got our x-axis, we've got our y-axis, and then we've got the z-axis. All right, so we've got the parabolic cylinder x equal y squared, okay? And so that's going to look something like this. I bet I'm going to really butcher this thing drawing it. Okay, something like this. Kind of make it look like it's coming at you. It may be kind of slanting down a little bit. And so we can connect that. We've also got the plane x equal 1, z equals 0. So let's see, we'll have a, let's see if we can't draw this halfway decent anyway. I don't know, maybe something like this. I'm not very good at drawing these things, so there's your plane x equal 1. Okay, this right here, this top part, that would be your plane z equal x. Okay, and it's going to z equals 0. All right, and it's hard for me to draw this thing, but anyway. This is 1. This is x equal 1. This is this top here. That's your plane z equals x. That's the top of this thing. I guess you could say it's kind of, you know, as x comes out 1, z goes up 1. X comes out 2, z is 2, and so on. Well, I know we're just going out to 1, but notice as we come out on the x, z is getting larger and larger, so it's kind of slanting up like that. And this is x, this is y, and this is z. Okay, so if we do m, okay, so it wants us to find the center of mass. So we got to find the mass, and then we got to find the moments, and then we can divide them. Okay, but the main thing that I'm going to be focusing on in this problem is just setting them up, is it. Okay. All right, and let's see. All right, so it's gonna be we're gonna have a triple integral, and let's integrate with respect to z first. So I don't know if I'm going to be able to draw this very good, but it's like we're coming up like this. See, from the bottom here, we're coming from the xy plane. We're coming up to this plane here, z equal x. Okay, and so we're going to integrate with respect to z first. So you can see we're going to go from 0 up to this plane right here. You see that, up to this plane. So that's up to, what is z? Z is x. So that's going to be x. And it's a constant density. So that's just rho. And we're going to integrate with respect to z first. Okay. And then we're going to integrate with respect to x. Notice we got a limit here of x. So let's integrate with respect to x next. And so what we'll need to do is we will need to look at this in the xy plane. So this is a parabola. See, here's your y-axis, your x-axis. So you see it's a parabola opening in the positive direction on your x-axis, like that. And it's bounded by the line x equal 1. Okay, see, they tell us that right here. All right, so for this one, we're going from here to here. We're integrating with respect to x. So we're going from this graph all the way out to 1. So what's x? Remember, this is x equal y squared. So x is what? Y squared. So we're going from y squared, see that here, y squared, all the way to 1. And then we integrate with respect to y. Well, what's y? Where does it intersect? We need this one and this one. And we know when you set y squared equal to 1, y is equal to plus or minus 1. And so the y term is going from -1 to 1. And there it is. It's set up. And your answer is actually 4 times rho over 5. And then if we want m, y, z, well, it's going to be the same thing. Your limits on your integrals are going to be the same. They're going to be exactly the same. It's just we're going to do x. Ooh, and this should be a dy right here. We're going to do x times rho times dz times dx times dy. And that should be 4 times rho over 7. And then if I do m xy, oh, what happened? Program crashed. We were working it too much, weren't we? All right, so let me write this down again. myz, that's -1, 1, y squared 1, 0x, rho, dz, dx, dy, and I need a dy here. and that is equal to 4 times rho over 7. And then if I do mx y, that's going to be the same thing. Negative 1 to 1, y squared to 1, 0 to x. Oop, and I forgot here, let's see, that should be x times that. And this one, the xy, that should be z times rho dz dx dy. And that would give you 2 times rho over 7. And then if we do mxz, that's going to be the same thing. Negative 1 to 1, y squared to 1, and 0 to x. And this would be y times rho dz dx dy. And that would equal, well, when you plug that one in, you're going to actually get 0 there. And then your well, let's see. Well, I tell you that when that thing program restarted, messed my screen all up. But anyway, x bar, y bar. I'm not starting this video over. And so that would be 5 over 7, 0, and 5 over 14. Yeah, I've already got a little bit of editing to do on this video. I'll go ahead and tell you, for those of you that stayed to the end, I don't know if you want to hear it or not, but anyway, I was sitting there working and I saw a mistake in the way I typed up wrote up one of the problems. And so I paused the video to double check and, pause my recording to double check and put it in. And then I went back to doing the video and I never unpaused it to start recording again. I was just working through that problem and everything. And then I noticed the time wasn't running, so I had to go back and fix that. And so now I don't know if I'll have to fix anything here or not, but I'm not going back and redoing this video. It was too long, but hopefully it helped. But yeah, the main thing is, I know I didn't evaluate some of the integrals, but that you should know how to do by now. Setting them up. That's what you're going to need to practice on, is setting them up. So I hope this video helped. Oh, and before I leave, just remember, where did I get these? It was this divided by this divided by this, and this divided by this, okay, to get the center of mass. All right, so hopefully everything helped. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching, and I will see y'all in the next one. Later.